Hello guys, so today we are gonna see how neutralization process happens and also see how two indicators work. So let's start. So this is app that is Unreal Chemist. So in this I am going to show you. So let's start. So I will go to lab experiments and this, and I'm gonna put some water over here. So now I'm gonna put an acid. So I'm gonna put acetic acid, which is diluted. I'm diluting it. Okay. So now, just a minute. Yeah. So water over here. Now acid over here. Acetic acid. CH3COOH. Okay, now let's put an indicator that is litmus. So it is expected for acid to turn red. So let's check. So here, as you can see, it has turned red. If I add a base over here, so neutralization would happen. So let me just first clear over here, and so how base to solution. Okay. After adding this base, I'm gonna put an indicator that is litmus. So it is expected to turn blue. As you can see, it has turned blue. Okay. So now let's see another indicator that is pH level indicator, which is universal indicator. So let's check it first. So we're gonna put pure 100% acetic acid over here, and then I'm gonna use a universal indicator. It is expected to turn red. Let's check. Okay. So as you can see here, it has turned red. So after turning red, let's add some water over here. So as you can see, it has painted. Let me just clear over here. Okay. After clearing it, I'm gonna put a salt over here. So I will put ammonium acetate. It is a pure form. So it is expected to turn green because it's neutral. So as you can see, it has turned green, which is neutral. So I'm just drain it over here, and gonna put I'm going to put I think it is zinc, and it is expected to. It's not working this water, so I think it can work in sulfuric acid because the strongest acid and the king of acids. Let's put it over here and use neutral, that is zinc. Just pour it over here. So as you can see, it's reacting. As you can see, it's reacting. So now let's check with indicator and see the water indicator. As you can see, it's a weak acid. It's getting weaker because of reacting with that. Okay. So now let's make a piranha solution. To make a piranha solution, you need two acids, that is hydrogen peroxide, which is H2O2, okay, in which there are two more atoms of hydrogen and two atoms of oxygen, which combine to make one molecule. So after adding granite over here, let's restart over here, or the beaker should be clear. So hydrogen peroxide over here. Okay. As you can see, I've added hydrogen peroxide. Now let's add some water, like this 3 drops. Okay. So after adding some water, let's add sulfuric acid. After adding sulfuric acid, let's check the indicator level. Indication level. We're using a universal indicator. As you can see, it's like a weak acid. Now let's put some sugar over here. As you can see, it is getting dissolved and reacting with it. Now let's put a milk over here. Milk is not sufficient as salmon fillet. We just put it over here. As you can see, it has started dissolving over here. As you can see, and bad things are coming out. As you can see over here, just clear it. Now let's neutralize a substance. So let's neutralize citric acid. So citric acid, it's not there over here. So let's use acetic acid. Or okay, let's use citric acid. Put it over here. Okay. After adding this, let me just put indicator over here. As you can see, it's a strong acid. So let me just put a base over here. It's barium oxide. So barium, I will put ammonium hydroxide over here. I will put it. As you can see, neutralization reaction is happening slowly. As you can see, the red is getting fainter. It's getting fainter. So after adding some more over here, let's check it over here. We will add okay. So see, as you can see, it's getting fainter. Let's put a lot of this ammonium hydroxide. So as you can see, temperature level is increasing. So let's check. Show you. As you can see, it was increasing over here. Okay, so let's put some more over here. Let me just put some more base. Like now, I will put a strong base. Let me just put magnesium hydroxide. It's a strong base. It is used to add acid, in which it is used to adjust our, when we have like we can say weak acidity, we use it. So let's add over here. Let's stop it. Okay. As you can see, it's getting greener. It's getting greener slowly. Okay. As you can see, it's getting greener slowly. So, as you can see, it has got greener, and it was there for some time. Let's put it over here. As you can see, temperature is rising. As you can see, temperature is rising over here. It's getting red. And more. Yes, you can see over here, it got perfectly greener. Now the substance has neutralized. Now the effect has gone over here. Let's put a lot. Okay. As you can see, the effect is coming now also. It's coming. So as you have seen over here, it's now again painting. Now let's add. As you can see, it got greener. So we just drain it over here. As you can see, it's neutralization process. So let me add some hydrochloric acid over here and mix it with NaOH. That is sodium hydroxide and HCl. So let's mix sodium hydroxide over here. As you can see, reaction is happening and bubbles are getting, and as you can see, temperature is also rising. Temperature is rising because of it. So let me just put a universal indicator. It is a strong, you can see a strong acid. Let's put more sodium hydroxide over here. Okay. As you can see, it's getting greener. It's getting greener slowly. Let's put more. Yeah, as you can see, it's getting greener. So in further videos I will also show in real life how neutralization happens. As you can see, it has got perfectly green over here. So let me just empty this. Okay. So as you can see, temperature is dropping slowly. As you can see, when I'm just tapping over here, the temperature is increasing like this. So as you can see, acid and basis reaction. So what happens in neutralization is that, like, when we put an acid or strong base like HCl plus H means hydrochloric acid plus NaOH, that is sodium hydroxide, a reaction happens, that is neutralization. This reaction is called neutralization. So when neutralization happens, salt, water is produced. And salt is NaCl. Okay. So let's check using a litmus indicator. So this litmus is very good indicator which is used broadly, which is obtained from plant, that is lichen. So let's use put a strong acid, that is sulfuric acid. Let's check whether organic substance can dissolve in sulfuric acid. So let me just put okay. As you can see, I have put a lot of sulfuric acid. So let's add some cherry over here. As you can see, reaction started. And the temperature is going. Let me just put more temperature. So reaction can happen faster. Let's put the time also faster over here. As you can see, reaction is getting very fast. Let's make it more fast. Okay. As you can see, the reaction is very fast. Okay. As you can see, reaction has stopped over here. So if I put more over here, like if I put a milk over here, let's check what happens. So this sulfuric acid is not that good. So let's pour it over here and remove all the contains or reactants from the beaker. So let's add new sulfuric acid over here. This is H2SO4 here. So now let's put organic like milk over here, which is, as you can see, the temperature is rising and it's getting very fast. As you can see, black fumes over there. So let's put, like, you don't have to put indicator first, then put acid, as a blast could happen using that. So let's first pour the acid or base, then use indicators. So let me just put again the sulfuric acid along with it. And now let's put equal quantity of base over here. So I'm gonna put sodium hydroxide, which is strong base. Over here. As you can see, I have put a lot of this base. So let me just put litmus over here. As you can see, neutralization it has turned to base over here. As you can see, I'm just put a small amount of sulfuric acid over here. So as you can see, it has the solution and neutralized, as it has turned normally blue over here. So drain it over here. So let's check what happens if a strong base is over here. Okay. So I put a strong base. And now let's put litmus indicator. It would be very dark. As you can see, it's very dark. Now let's put with acid over here. Let's put a strong acid that is inside our stomach, which is hydrochloric acid. As you can see, I have poured it over here. And let's put a litmus indicator over here. As you can see, it has turned to strong red. Now let's neutralize over here. I'm going to use potassium hydroxide. As you can see, I have used potassium hydroxide over here, and it has changed color. It has started changing color. As you can see, it has turned now base. It has turned base over here. As you can see, it's starting to turn base and getting neutralized. As you can see, it is perfectly neutralized as it turned the color of litmus paper over there. Now let's check with phenolphthalein. So it is expected in phenolphthalein to get normal, to be normal in acid. So let's check it over here. As you can see, it is normal. So now let's drain it over here and put a strong base, that is potassium hydroxide, and just pour it over here. Okay. Now let's put phenolphthalein and expect it to turn pink. As you can see, it has started turning pink. Okay. So now let's try with another, that is this cresol red. So let me just put first hydrochloric acid. Hydrochloric, like it is like 50% water, 50% hydrochloric acid. So let me just put this cresol red and expect it to turn yellowish, as you can see over here. So we just drain it over here, and it is expected to turn purple when a base is over there. So let me just put lithium hydroxide, which is 50% lithium and water. So as you can see, I have poured it over here. Now let's put an indicator, that is cresol red. It's ready to turn C. I told you it has just expected to turn purple. Now let's put a strong base, like let's put sulfuric acid. As you can see, neutralization has started over here. So see, alkaline, all the alkaline substances are bases, but not all bases are alkaline. Remember this point. So as you can see, temperature is rising. Temperature is slowly rising over here. As you can see over there. As you can see, temperature is rising. So utilization is happening over here. So I have removed all the reactants over here. Now let's try putting the other round. So let's put universal indicator first and put hydrogen peroxide over here. Sorry. Let me just put over here litmus. Okay, I put litmus. Now let's put some acid over here. Let me just put hydrochloric acid. Okay. As you can see, it is reacting, but in real life, it's in the game. So in real life, it explodes. Okay. So now let's try our CF periodic table over here. So as you can see, so these are all like radon, rubidium. So these all have been discovered, which are like this have been discovered like by mankind, or we can say laterally it has been discovered, and tell me where argon is used. So argon came from a green word, that is agos, which means inactive or lazy. So argon is mainly lazy, which it is we can say non-reactive gas. It is used in incandescent light bulbs which produce yellow light. So it's the type of a gas. So it's a density of 0.86. It has a property of 0.86 grams centimeters cube. Okay, and valency is 0. As you can see, this is argon. Okay. It is electron shell over here. Okay, so let's move it back. As you can see, over here, it's very fun. As you let's move it over here. So it is using bulb. So you can see combined visible spectrum. As you can see, spectrum is over red to trim the length. Now as you can see, we are going to trim this length. So you can also turn over here and let's put it together. So it will not work. So just put it next. As you can see, Ca, that is calcium. It was calcium over here. It is calcium over here. So okay. So let's check what was discovered by Marie Curie. So Marie Curie discovered polonium and polonium. Okay. So Marie Curie discovered polonium. Let's check this polonium. Polonium. So let's check polonium. So tell where tin is used. Tin is when you burn it, it is used in soldering. So tin is used in soldering. It is mainly found in China region. Polonium is over here. As you can see, polonium is highly reactive. So Marie Curie reacted with like this. You can see polonium over here. So you can see Marie Curie discovered a node. So it's metallic over here. Let's put it dark over here. And you can see it is a metal over here. The density is around 9.3 grams per centimeter cube. So melting point is 254 degrees Celsius and boiling point is 962 degrees Celsius. As you can see the electron shell over here. Let's put over here. As you can see the wave spectrum over here, visible spectrum. Okay. So let's check some other plutonium. No. Krypton is checked. Where is krypton? Here is krypton. So it is a colorless gas and non-metal. So this you have heard a Superman movie where a dog named Krypton. So krypton means cryptus, which is mean hidden. Okay. So its density is 3.75 grams per centimeter cube. So as you can see over here, electron shell. So it's very fun to see this over here. So now let's mix again. So now we're gonna mix some salts over here. Let's play with colors. So let's put some water over here and put copper acetate over here. As you can see, color is not changing that fast, but it would be neutral over here. So that means put litmus over here. As you can see, it is neutral. As you can see over here, I put this also. Let's put pure copper acetate over here. As you can see, it's beautifully blue colored. I will just put universal integrator over here. As you can see, it's neutral substance. As you can see over here, but we can say slightly acidic it is. Slightly acidic. So let's put some milk over, not some sugar over it. As you can see, it has changed color over here and turned base. To tell me why it has changed, I must put almond, not dissolvable. That was big sugar over here. What has dissolved? Not changing to base. It is changing to base. Let's put much. As you can see, it is not dissolving more. It is not dissolving more because it has turned over here. As it has turned a saturated solution. Now let's make a super saturated solution. Let's heat it over here. As you can see, it has started heating. As you can see, sugar will start getting dissolving over here. Let's put a sugar over here. It will get cold though. More heat. It is not working over here, but in real life it works. Make it cooler over here. So let's add some water over here. Now let's add cool water. And now let's check that the solution in this water. So when you add sugar over here, and add more sugar. And let's add some universal indicator. So as you can see, sugar is like a base. Sugar is a base, it's turning to base. Okay. So if I add some water, full beaker of over 250 ml of water. Okay. So I filled water with 250 ml. So if I did 250 ml, now let's add some organic water of the sugar. Add more till that it is not dissolved over here. Your time is not dissolved. Okay. Now add more. Sorry, not add this. Don't add this. It will not dissolve. Now let's add more. It's still dissolving. More. So as you can see, the stop dissolving over here. Now let's start heating it over here. And let's check as you can see that it's saturated. Now let's make it super saturated solution. Let's add this. Make it now and let's add sugar. Now let's add some acid also, sulfuric acid, to make this process faster. As you can see, this process is getting faster, and the gas sprout out. So now let's take a lagging fast effect over here. Heat it more. Heat it as much as you can. Now let's add some water over here. It's getting heated. Now let's drain it over here. Now let's add. As you can see, really first effect was in the action. Let's add some more to make it warmer. Okay. So that's got warm. Now let's add. As you can see, really first there was an action. So let's take a break from this and let's change color of the fire over here. I don't know how this white is color. Now let's add the boric acid also. Boric acid, now let's add boric, and let's put it fire. As you can see, it's blue in color. Now let's add boric acid over here. As you can see, the color has changed to green. Now let's add some sprinkles. As you can see, it has changed. So let's add some salts over here like copper chloride. As you can see, it has turned light blue. As you can see, it's got fun over here. So now let's get over here. So you can play with this game. It's fun game. Okay. So for today, it's like 30 minutes video. So let's take a break. So bye bye. Thank you and have a nice day.